All right, everyone, welcome back. Today we're going to be going over lesson 6, which is multiplying and dividing rational expressions. So we already did simplifying rational expressions. This is moving on to multiplying and dividing those expressions. If you could look here in your textbook, this is going to be the homework questions from the McGraw-Hill textbook, with special focus on 3CD and 5CD if you're finding it a little bit easy. Number 1 and number 2 are really great practice questions if you're still trying to get a hold on the concept. So the idea by the end of this lesson is you should be able to multiply and divide rational expressions using the step-by-step method. Can you give your answer in the most simplified version of the expression? And last but not least, make sure that you're stating the restrictions for all steps and then having a statement at the end with all of them in. So in order to multiply and divide rational expressions, there is 5 steps. You'll notice that for number 2, there's kind of like a subsection. That's important. So always when you're starting with them, you're going to factor fully, which means that you're going to factor the numerator and the denominator completely for both of your terms that you're multiplying or dividing. Then you're going to go ahead and you're going to state your restrictions. If you have division present, you actually need to state your restrictions twice. The first time you need to state your restrictions is you're going to have to state your restrictions regularly for both of the terms. And then because you're going to be using the keep, change, flip method, you need to make sure that when you flip that second fraction, you're also stating the restrictions again. So after you flip in division, you need to make sure that you are stating the restrictions again. You only need to do that if you are dividing. If you're multiplying, you can state them once, move on. Okay, then you're going to go ahead, same idea. You're going to divide out any common factors that we have, simplify, make a statement with the restrictions again, and have a final statement at the end. Okay, so just for us to recall, when we are multiplying and dividing fractions, we want to make sure that we are doing it correctly. So when you're multiplying, you can start by just multiplying the top numerators and the bottom denominators. What I like to use is the butterfly method. So I like to make it easier for me to do the multiplication. I see here that the 15 and the 25 are both factors of each other. So I can divide 45 by 15 and 15 by 15. So I get 1 and 3. Here I can see that 16 and 12 are similar. They both have a common factor of sorry, that should be 3. They both have a common factor of 4, so I divided both sides by 4, right? And now I can just simplify and go 1 times 4 is equal to 4, and then 3 times 3 is equal to 9. If you had done 15 times 16 over 12 times 45, you would have gotten a larger number, and then you could have divided down to 4 over 9, but I just find this easier. Okay, when you're multiplying or dividing fractions, you need to make sure that you keep the first fraction, so we keep it as negative 5 over 8. We change the sign and flip that last fraction, right? So we're going to have the same idea here. 5 and 3 don't really have any common multiples, but 8 and 4 do. So I'm going to reduce this to 2 and 1. So then I'm left with negative 5 over 2 times 3 is 6, negative 5 over 6. Okay, so that's just kind of how we can reduce and simplify and solve. Okay, when we're simplifying, let's go ahead and try doing this together, right? You can again look at these and say, okay, we have the 2 and the 14. Those two are going to cancel out. I know I'm going to be left with 1 and 7. For the a's, we can cancel this one out. We're left with a squared and just, oops, sorry, a and just a squared is going to go away. Right? The 9 and the 9 here we can get rid of. We can have 1 and 3. B squared cancels out and you're left with 1 here. So I know that what I'm left over with is 3, 1 times 3, A, B divided by whatever's left over on the bottom, which is 7. Again, if you had done this the other way, which I'm also going to show you, you're going to get the same answer. So if we just did this and we multiplied the top terms, we'd get 18. A cubed over b cubed divided by 3 times 14 is 42. B squared, a squared, so a squared, b squared, right? And then if we were to reduce this out, we could reduce this over to 3 over 7. The a cubed, 3 minus 2 is going to be a, b cubed, b squared, we're left with AB, right? And our restrictions would be such that B squared cannot equal 0 and A squared cannot equal 0, right? Or well, 3B squared and 14A squared. And I know that if I isolate for our 3B squared, I know that B cannot equal 0 and A cannot equal 0. So those are going to be my restrictions that I'm going to include in my final statement. Oops. Okay, so that's my answer right there. My final statement. So pause here and try doing this one on your own. I'm going to do it using the butterfly method. You can do it using whatever way you want. I just find the butterfly method to be easier for me personally, so I'm going to do it that way. So here I'm going to take this, reduce this to 4 and 3. I can't really do anything with the 3 and the 5, so I'm going to leave them as is. So 4 times 5 is going to give me 20. X squared times x cubed is going to give me x to the power of 5. And then again, 3 times 3 is going to give me 9. Y squared times y is going to give me y cubed. I also need to make sure that I state my restrictions. Cannot equal 0, so I know y cannot equal 0. And then 6y cannot equal 0, y cannot equal 0 in that situation too. So it's just y cannot equal 0. And that's going to be my final statement. Okay, so those ones are fairly easy because we actually don't have anything that we've been really factoring. We've kind of just been multiplying them out. So as we move on to a little bit more complicated ones, we're going to be doing this one together, and then I'll let you try this one on your own. And again, the solutions are posted, so be sure to go back and look at them. This one's a little bit tricky because it is division, so you need to make sure that you're stating your restrictions the first time when you are multiplying, and then the second time when the first time when you have that division, and the second time when you're flipping it to do the multiplication. So we will go over this one together. So how I like to do this personally, I like to split these up. So I factor the first one. We'll do that in pink. We'll do the bottom one here in green. And then we'll do this one in blue. We don't really have to factor anything out there, but whatever, for the sake of this video, we'll do that. And that one's going to be in orange, right? So we factor all of them out. So let's start with number 1, which was our pink one. I'm just going to go here and pick a pinker color. Okay, just easier to read. So we're going to factor out number 1. So we have x squared minus x minus 6, right? If I look at this, m plus n is going to equal -1, and times n is going to equal -6. I know that my factors are going to be -3 and +2, so I'm going to do x minus 3, x plus 2 for my first portion. Then I'm going to go ahead and factor out that bottom one in green. Okay, so then I know that I'm going to be left with two numbers that when they add together are going to give me -2, and when they multiply together are going to give me -15, right? We're just doing m plus n. And again, this is simple trinomial, so we can just go ahead. We don't have to do any decomposition here. Okay, we're left with x plus 3, x minus 5, right? And that's going to be our top right there. The rest of them, we don't really need to go ahead and do any simplification because x minus 5 you can't factor any further, and x plus 2 you can't factor any further. So let's just go ahead in our third step over here, put them all together, right? So we have x minus 3 times x plus 2 divided by x plus 3, x minus 5, all multiplied by x minus 5, x plus 2, and I like to just go ahead and do my restrictions. You should do your restrictions right here. So this cannot be -3, this x cannot be +5, and here x cannot be -2. So now that we have our restrictions done, we can just go ahead and start canceling stuff out. Because this is all multiplication, I don't have to flip anything here or restate my restrictions. I can just straight cancel that out, and I'm left with x minus 3 over x plus 3 plus all these beautiful restrictions that I have. So I'm left with x minus 3 over x plus 3, and I always like to write it as a therefore statement, x minus 3 over x plus 3, and then my restrictions here are going to be such that x cannot equal negative 3, negative 2, and positive 5. And that is going to be my final statement. So very similar to simplifying, except now you have multiple terms, so you need to take that into consideration. If this had been a divided by symbol, we would have had to flip. So if this had been divided by, we would have had to flip it here, and then we would have had another restriction of x cannot equal positive 5, which we already had. But that's how those restrictions apply if you're going to do that. So I'm going to let you try and do this one on your own. Actually pause the video here, actually try to do it. The answers are posted online, so I will not be posting these answers here. I just want you to attempt to do it by yourself because, actually, maybe I will do it here. I want you to attempt to do this by yourself. So like actually pause the video here, try going through it on your own, and then come back and see if you had done your answer correctly, and then you can go through it together. Okay, so again, I like to split these up so I have the top, the bottom, we'll use the blue over here and the orange over here. And this starts to become more tricky because now you have to factor 4 different things. So let's go ahead and do that. I'm going to do it more methodically here because we can. Honestly, I've gotten to a point where I can just do it by myself and like have them where they are, but we're going to do them together. So we have x minus 4 minus 4x plus 4. Oh, sorry, x squared minus 4x plus 4. So we're going to try to find two numbers that when they add together, they give us negative 4. So in the interest of showing you how I'm getting this, again, you do not have to show these steps every time you do it. It's just, this is for clarity. And we know it's a simple trinomial, so it's just going to be 4, right? So two numbers that when they multiply to give me negative 4, but add to give me, multiply to give me positive 4, add to give me negative 4, we know are going to be negative 2 and negative 2. This is also a perfect square trinomial. So we can factor this into x minus 2, x minus 2. Right, moving on to our green one, that's a difference of squares, right? X squared minus 4. So we take the square root of the first term, square root of the last term, plus, and the other bracket is minus. Okay, then we have the x squared minus 5x plus minus 6. I think I did that in blue, right? So 3x squared minus 5x minus 6. Again, two numbers that when we add them together are going to give us negative 5. When we multiply them together are going to give us negative 6. And we know that can be negative 6, positive 1, right? So this can be x minus 6, x plus 1, right? And then last but not least, we have the one that was in the orange. So I'm going to go back by my orange marker. So I'm just going to try to squeeze it in here. We have x squared plus 5x plus 6, and those pluses make all the difference. So we have two numbers that when they add together, they give us positive 5 now. When they multiply together, they give us positive 6, and we don't know those two numbers are going to be 2 and 3, so I'm left with x plus 2, x plus 3. Now that we have factored everything fully, I like to go back and put it back into that original format that we had. So I'm just going to go here, and we're going to put the pink at the top, so it's going to be x minus 2, x minus 2. You can also write this as x minus 2 squared. I just find it easier to work with them if they're split up like this. X plus 2, x minus 2, divided by x minus 6, x plus 1, all over x plus 2, sorry there, x plus 3. Now we're going to go ahead and we're going to make sure that we state all of our restrictions. Because now that everything is like, before we start crossing things out and flipping things, we always want to make sure that we state every one of our restrictions. So here we know that x cannot equal negative 2. They're the same. This should be plus 2. This is minus 2, sorry. oops, this is also x cannot equal plus 2, right? Because they're the two opposite signs. Here it's the same as x cannot equal 2, so I won't bother writing that back in. And here x cannot equal -3. Now, because we're dividing, we're going to have to flip this entire second fraction. Okay, so let's do x minus 2, x minus 2, all divided by x plus 2, x minus 2, keep, change, the x plus 2 comes on top, right? I just took this, put it here, took this, put it here, just to show you that. I'm just going to go ahead and put it in the color so you don't get confused. It's going to be the orange goes now at the top, the orange goes at the top, and the blue portion will go at the bottom, so it's going to become x minus 6, x plus 1. And now because I switched my denominators, right, and because I switched and had a reciprocal here, I need to make sure that my restrictions are restated in this situation. Okay, so x also cannot equal positive 6, x also cannot equal negative 1. Okay, so now I have 1, 2, 3, 4, 5 restrictions instead of just the 3 that I had on top. Okay, now I can go ahead and start crossing things out. So I can cross this plus 6 over, or plus 2 over here. This I can cross out over here, and that's really all I can cross out. So I'm left with x minus 2, x plus 3 at the top, and at the bottom I'm left with x minus 6, x plus 1, and my restrictions, I'm going to go state all of them. X cannot equal -2, oh, sorry, I'm going to state it like this. X cannot equal -3, -2. I always put them in a set. You should put them in ascending order of, so the numbers are like that. Right, so those are all your restrictions, and that will be your final answer for this right here. Okay, so just notice how when you're dividing, you need to do it twice. So again, here we're just going to write the area of the rectangle in simplest forms. This one is similar. You just need to remember that what is area, right, of a rectangle. We know that area of a rectangle is equal to length times width. So we're just going to go ahead and label. So this is very simple. It's just multiplication. Okay, so area is equal to length times width. So we'll say area is equal to x squared minus 9 divided by x multiplied by x cubed minus 4x divided by x squared plus 5x plus 6. So let's go ahead and just factor. The x squared minus 9 is a difference of squares, so it's going to be x minus 3, x plus 3, all divided by x, multiplied by, we can pull out an x from the top, and we have, if we take an x out of here, we're left with x squared minus 4, which is also a difference of squares, so it's going to be x minus 2, x plus 2, all divided by x plus 2, because we're taking the x squared plus 5x plus 6, which is just x squared plus 3. Okay, so again, we're going to make sure we go ahead and state all our restrictions. Here, we know x cannot equal 0. Here, we know x cannot equal -2. Here, we know x cannot equal -3. So we have 3 restrictions here, right? And then we can just go ahead and start canceling things out. So we have an x plus 3 here. We have the x and the x that we can cancel out here. And that is really, oh, and the x plus 2 and the x plus 2. Almost missed that. Okay, and then so that's all we can cancel out. So we're left with x minus 3 over x minus 2. And since there's nothing left in the denominator, it's just over 1, which we don't need to write. And our restrictions are going to be x cannot equal 0, 2, or -3. And that's going to be our final therefore statement. Right, and that is it. So for this one, because it is a word problem, we do need to write in therefore the area in simplest terms is x minus 3, x minus 2, such that x cannot equal 0 to sorry, this should be negative 2 here. Negative 2, negative 3. It's just not letting me write it the way I want to. And that's the answer. Okay. All right. So again, go back and try doing these homework questions. 3CG and 5CG are a little bit more tricky, so try those first. The only thing that you really need to remember is that multiplying, you only really need to state the restrictions once. With division, you have to do it twice because you got to do that flip. All right. Thanks for tuning in. Bye.